In this tutorial, we are going to talk about linear momentum. So, what is linear momentum? So, let's say you have got an object. This object is moving in this direction. Remember, this object is going to have a mass. At the same time, this object, since it's moving, is going to have the velocity. Okay? So, when something is moving and that object is having the mass and the velocity, then we have got what we call the momentum. So, momentum can be defined as the product of mass and the velocity. Now, this momentum is represented by the symbol P. So, momentum is a vector. It can be negative or positive. Okay? So, momentum is a vector, and remember, we said that vector is a physical quantity which has got both magnitude and direction. Okay? So, momentum being a vector, we know that it can be negative or positive. That is just okay. So, we are saying that momentum is represented by P. So we are saying that this is mass times the velocity. So this is the momentum. Okay. Now let's talk more about momentum. We do know that mass is in kgs, velocity is in meter per second. So we can see that this momentum, the SI unit, is just basically kg meter per second. That is very, very important. Okay, now let's talk more about this momentum. Okay, now when we talk about momentum in general, we are saying that if an object is moving, it has momentum, which is mass times, let's say, the change in velocity. So this change in velocity, we might say, is the final velocity minus the initial velocity. Okay, then there's also what we call the impulse. So there is a relationship which is there between the impulse and momentum. Okay, so impulse is the same as momentum. Now let's talk more about the impulse first. Okay, so we are saying that the impulse, this guy so-called impulse, represented by symbol I, is given by the force times the change in time. So momentum, we can say change in momentum is the mass times the change in velocity. So we are saying that impulse is equal to the change in momentum. So impulse is the same as the momentum. Now let's say if this is the same as the momentum, we can say that we are saying that momentum is the force times the time. So we can say that this is the force times the change in time. The momentum is mass times the change in velocity. Okay, I can find the force. I can divide both sides by the change in time, even here by change in time, and I'm going to find that the force, the average force, is going to be the mass times the change in velocity, everything divided by the change in time. Now I want to show you how this formula is coming about. There we go. So now in general we are saying that the average force is given by the mass times change in v, everything divided by change in time. But remember what is on the top there, that's basically the change in momentum divided by change in time. We know that force is equal to mass times acceleration. Let's pick it up from there. So we know that acceleration is given by the v final minus the v initial, everything divided by time. So let's say this is change in time. So what I'm going to do is I'm going to replace this with my acceleration there. So I'm going to have the force to be equal to mass, open brackets, the v final minus v initial, everything divided by change in t. Okay, now I can see that if I distribute m, this is going to be m v final minus m v initial, everything divided by what? Divided by change in t. But at the same time, the mass is the same, but the velocity is changing. So we have got the change in velocity, which is the same as, we can say that the force is given by the mass times the change in velocity, everything divided by change in time. But what is mass times change in velocity? That is the change in momentum, everything divided by change in time. So this is how the formula for the average force comes about. Now, so force is in Newton. That is very, very important. Time is in seconds. So we can use dimension analysis to see, to prove that if you have got the average force is equal to the change in momentum divided by the change in time, it's going to give us newtons. Let's see. So if I have my formula, which is the average force to be equal to the momentum, and we know that the momentum is kg meter per second, and the time is just basically in seconds. Okay, so if time is in second, we can see that the average force is going to be newton. How? This is what we're going to have. Okay, so the force is mass times the acceleration. So the force is going to be, mass is in kg, acceleration is meter per second squared. Now this is what I want us to come up with here. So we can see that this is going to be m, then we are going to have this second, and this second is going to be s squared. So we can see that kg meter per second squared is going to give us 1 newton, which is just the same as what we have there. Okay, so in general, what we are talking about here is that the momentum is just basically mass times change in velocity. Then the impulse is the force times the change in time. And we are saying that impulse is equal to the change in momentum. Okay? So we can say that change in impulse is equal to change in momentum. So the impulse is force times the change in time. This is going to give us mass times the change in what? In velocity. Now you can use this to find whatever you want to find. If you want to find the force, you have been given the mass with the velocity and the time, you can find the what? The momentum. The force. As simple as that. Now I've got some few questions here. Let's see how we can solve them. So I've got the first question, which is saying a golf ball of mass 5.0 times 10 raised to the power negative 2 kg is struck with a club as shown in the figure below. Although we don't have any figure here, so we can just exclude this. Okay, now the next point is saying the force on the ball varies from 0 when contact is made up to some maximum values, when the ball is maximum deformed, and then back to 0 when the ball leaves the club, as in the graph of force versus time. Okay, so you can also exclude this part here. We no longer need this. Assume that the ball leaves the club faced with the velocity of 44. This one is supposed to be plus 44. So it's supposed to be plus 44 meters per second. But A, find the magnitude of the impulse due to the collision. But B, estimate the duration of the collision and the average force acting on the ball. Okay, so the last part is asking us to say use the momentum theorem to estimate the average force, which is the same as part B. So this question is just, we're just talking about the same thing. Okay, now let's start with the first part. Now the first part is asking us to find the magnitude of the impulse. Okay, remember, impulse is a vector. It can be negative or positive. Now let's come up with data first. We know the mass. The mass is 5.0 times 10 raised to the power negative 2 kgs. What else do we know? We know the velocity. So we can see that that is going to be the final velocity. The initial velocity is going to be 0. So the initial velocity is 0. The final velocity is going to be plus 44 meters per second. What else do we know? These are the only things we know. Okay, so the first question is saying find the magnitude of the impulse. So impulse is given by the force times change in time, but we don't have time. Remember, we don't have the force. At the same time, change in momentum is given by the mass times change in velocity. But remember, we said that impulse is equal to change in momentum. So I can use this information to find the impulse. Okay, I can say that impulse is going to be the mass times the change in velocity. The change in velocity, we're going to have the final velocity and the initial velocity. So I'm going to have the impulse to be equal to the mass v final minus v initial. Okay, now let's plug in the values. We see what we're going to have. So we're going to have the impulse to be equal to the mass is 5.0 times 10 raised to the power 2, open brackets. The final velocity is positive 44 minus 0. So let's see the impulse we're going to have. So we expect our impulse to be positive. Okay, so using my calculator I can see that 5.0 exponent negative 2, then times 44, I'm getting 2.2. So 2.2, remember this is the mass, this is the velocity, so it's going to be kg per meter per second. So this is my impulse. At the same time, this is my momentum. Momentum is the same as the impulse. So here, if they can ask us to find the momentum is the same as positive 2.2 kg meter per second. As simple as that. Part B is saying estimate the duration of the collision and the average force acting on the ball. Remember, I said part C and part B is the same, because here they are talking about we estimate the average force exerted during the impact, which is the same as the average force in part B. Okay, so now we can see that using the data which we have, now we have the momentum. We want to find the duration. Duration is just basically time. They want us to estimate. Okay, so we can see that the change in time, if we come to speed. Okay, speed is given by the distance. Okay, the change in distance divided by the change in time. So I want to find the time in this case. I'm just estimating, meaning let's estimate to say our distance is our change in distance. Let's say it is 3.0 times 10 raised to the power 2 meters. We're just estimating. You can use any distance. We're just estimating. So I want to find t. I can say that my change in t will be equal to the change in x divided by the speed. The speed we have there, which is 44. But the question is saying estimate the duration of the collision and the average force. So the average, meaning that speed which we have, we need to do times 2. Okay, so meaning the speed which we're going to use now is going to be 22. So we're going to have 3.0 times 10 raised to the power negative 2. Everything divided by the speed is going to be 22, because it's the average. The 44 we have divided by 2, that is what we're going to have. Using our calculator, 3.0 exponent negative 2 divided by 22. So I'm getting my time. I have to put this in scientific notation, which is going to be 1 point. So my change in t is going to be 1.36 times 10 raised to the power negative 4 seconds. So this is going to be my duration. Now, what of the force? After estimating the time, we can now estimate the average force. Remember, we said impulse is equal to the change in momentum. Impulse is the force times change in momentum, which is going to give us mass times the change in velocity. Now from here we can see that we are going to use the information which you have, which is going to be, I'm going to divide both sides by change in t, even here by change in t. So the force is going to be equal to the mass times change in velocity over the change in time. Okay, so the force is going to be equal to, what is the mass? The mass which you have is 5.0 times 10 raised to the power negative 2. Then the velocity now which we have is positive 44. So I'm going to divide this by the duration, so which is 1.36 times 10 raised to the power negative 4. Okay, that is our duration. So 1.36 times 10 raised to the power negative 4. Let's see what we're going to have. So we're going to have 5.0x to the power 2 times 44, then divided by 1.36 exponent negative 1. So I'm getting my average force to be 16,000. So it's going to be positive. Okay, it's going to be positive because the velocity was positive. So it's going to be positive 16,100 and okay, let's just put this in scientific notation to make things simple. So I'm getting 1 point, which is going to be positive 1.62 times 10 raised to the power 4 newtons. So this is going to be my what? My average force. So in this case, we are done with this question. Now remember, part C is saying use the impulse momentum theorem to estimate the average force. So this is the same as what we have found here. So the answer for part C and the answer for part B, we have two for part B. The duration, which is the time, and the average force. So the force which we have found there is the same as the force which we have found on part C. So now, in general, they just made a mistake putting question C here. Okay, because it's already there in part B. Okay, so let's see if we can solve another question, which is saying in a crash test, a car of mass 1.5 times 10 raised to the power 3 kgs collide with a wall and rebound as shown in the figure below. The initial and the final velocity of the car are: the initial velocity is negative 15 meters per second and the final velocity is 2.6 meters per second respectively. If the collision lasts for 0.150 seconds, find part A, the impulse delivered to the car due to the collision, and part B, find the size and the direction of the average force exerted on the car. So now again we can see that before collision we had the velocity which was the car which was moving due west, and we know that momentum, whenever we're talking about momentum and the impulse, we're talking about the vector, so the direction matters. Okay, so in this case this car is moving toward negative x direction or toward west. Then we can see that the velocity is negative, as you can see from here. Then after hitting the wall, it started now coming toward positive x-axis or toward east with the velocity of 2.6. Now this velocity has to be positive because it's now moving toward the positive x-axis. That is very, very important. Now the question is find the impulse. Remember, impulse is equal to change in momentum. Okay, so the change in momentum is the mass times the change in velocity. So the impulse is going to be, we have the mass, open brackets, this is going to be the final velocity minus the initial velocity. So impulse is going to be, the mass is 1.50 times 10 raised to the power 3, open brackets. What is the final velocity? The final velocity is 2.60 minus the initial velocity is negative 15. So this one is supposed to be negative 15 and not negative 1.5 here. Supposed to be negative 15 is 15.0. Okay, so negative 15.0, that is what we have. So my impulse is going to be 1.50 exponent times 10 to the power 3. Okay, or we can find what is inside first, which is 2.60. Then negative is going to be plus 15, which is going to give me it's going to give me 17.6. So 17.6 times the mass. Okay, so I was thinking maybe this is the velocity, but this mass is supposed to be the same the way it is. Okay, the mass is just like that. I was thinking maybe this is the velocity, so that is just okay. It's supposed to be 1.5 times 10 to the power 3. That is the mass. But the velocity, the initial velocity is negative 15. Okay, so it's 17.6 then times 1.50 times 10 raised to the power 3. So I'm getting my impulse. Now, since this is going to be positive, okay, because this velocity here, inside here we're getting positive, so it's going to be positive 26,400. So we have kg meter per second. That is going to be my impulse. Now the next question is saying, find the size. What is the size and the direction of the average force exerted? So to find the average force, let's not forget, so we know that this is the same as we have found the momentum. So the momentum, which is the same as the impulse, is positive 26,400. So I'm going to get rid of this. Now we want to find the, so we know that impulse is equal to change in momentum. Impulse is force times change in t, which is going to be equal to the change in momentum. Momentum we have already. Let's divide both sides by change in t, change in t. The force is going to be equal to the change in momentum divided by the change in t. So force will be equal to, what is our momentum? Our momentum is 26,400. We divide it by the time. So the change in time is 0.15 seconds. So this is kg meter per squared or per second. So let's see. The average force which I'm going to have, it has to be positive because the momentum is positive. So the average force is going to be 26,400 divided by 0.150, which is going to be positive 176, positive 176.00 newtons. So I can put this in scientific notation, and I can say that this is going to be my average force to be positive 1.76 times 10 raised to the power 5 newtons. As simple as that. Okay, so this is what you need to know, and the impulse and the momentum.